Hello everyone, this question is about the oil drop experiment, estimation of the size of an oil molecule. So the question reads, in an experiment to estimate the size of an oil molecule, an oil drop of diameter 0.05 centimeters spreads over water to form a circular patch whose diameter is 15 centimeters. Determine, then part A, the volume of the drop, B, the area of the patch, and C, the size of the oil molecule. So beginning with the first part, we need to take note that in the oil drop experiment, we'll consider the following assumptions. So the first assumption is that the oil drop is perfectly spherical. Secondly, the oil patch is perfectly cylindrical. And apart from being cylindrical, we'll also consider that it is perfectly circular. And we'll also consider that oil patch is a monolayer. So these will form the basis of our workings. So let's begin with the first part. So we have the volume of the drop calculated as 4/3 pi r cubed. So we are assuming that the oil drop is perfectly spherical, and therefore we use the formula for the volume of a sphere, and this we will have as 4/3 times pi. Let's use 22/7 times the radius. So the radius of the oil drop we're given us, so the diameter is 0.05, so we'll have the radius as 0.05/2, that is half the diameter, and then we cube it. So this worked out should give us 6.548 times 10⁻⁵ cubic centimeters. So that is the volume of the oil drop. We can again look at the area of the patch. Now, when the oil drop touches the surface of the liquid, that is water, it spreads, and when it spreads, it forms a circular patch according to our assumption. The diameter of this patch, we are told, is 15 centimeters. So the patch is 15 centimeters in diameter, and this will help us determine the area. Area is given as pi r squared, that is area of a circle. Remember, we had assumed that it is perfectly circular, so we are going to have 22/7 times radius squared. So the radius is 15/2, so we'll have it as 7.5 squared. A half of 15 is 7.5. So when we work out this, we should be able to get 176.7857, of which I'd wish to express in standard form, and that is 1.7679 times 10⁻², and this one is square centimeters. So finally, we are going to determine the size of the oil molecule. Once again, according to our assumptions, we consider that the oil patch is a monolayer, that is, it is one molecule thick. So when the oil drop touches the surface of the liquid, it spreads into a patch, and when it spreads into a patch, the assumption here is that the patch is cylindrical, and the height of the patch is equivalent to the diameter of each molecule. Remember, the assumption is that the oil patch is one molecule thick, or it's a monolayer, so that the diameter of this molecule is equivalent to the height of the oil patch. Remember, the oil patch is assumed to be cylindrical. So if we consider the size of the molecule as T, which is equivalent to the height of the cylinder, then we can say that the volume of the oil drop, which is equal to the volume of the patch. Remember, it is the oil drop that spreads into the patch, so the volume remains the same. And the volume of the oil drop we already had in the first part as 6.548 times 10 power negative 5. And that is equated to volume of a cylinder, which is cross-sectional area times the length or the height. So the cross-sectional area is just the area of the patch, which is 1.7679 times 10 power 2, and we multiply that by the height of the cylinder, and the height of the cylinder is equivalent to the thickness of the oil molecule, and that will be the size of the oil molecule. So dividing both sides by this, so we'll have these cancelling, and T, according to my calculator, if I work out this, I get 3.7038 times 10 power negative 7, and that is centimeters. And that finally gives us the thickness or the size of the oil molecule. Now with that, we come to the end of this question. Thank you for watching. See you next time.